The invention of LED lights is really a genius. It is compared with ordinary light bulbs, higher light efficiency, longer service life, and the volume is very small, very wide range of uses, so that now the streets and alleys can be seen everywhere in the figure of LED lights. To understand how it works, the lack of basic physical knowledge is really not. LED lights, also known as light-emitting diodes, then we have to understand the principle of ordinary diodes work. If we connect the light and power supply together, the electrons will be free to pass in the circuit. This is because the electrons can move freely between the metal atoms. But if we connect a diode, the current is affected by the difference in the direction of its connection. This is because inside the diode is a semiconductor material called silicon, but it is not pure silicon. Let's go into the microstructure of silicon atoms and look at it. You'll see that silicon has 8 electrons around each atom, and the 8 electrons are so stable and tightly packed that they can't even pass through the block of silicon when new electrons in the circuit reach it, which makes it an insulator. But we can change its conductivity by doping it with other elements. At this point, if we dope with elements that carry 5 valence electrons, then this atom has 9 electrons around it, which destabilizes the structure of the 8 electrons around the silicon atom. And this extra electron is unwelcome and not wanted by anyone, which also means it is freer than the other electrons. When connected to a power source, it acts as a moving conductor. Because of the extra electron, it is negatively charged, and we call this semiconductor an N-type semiconductor. However, if the element with trivalent electrons and silicon doping, then the atom around the possession of 7 electrons, which means that compared with the most stable 8-electron structure, less than an electron out of the gap at this time, this gap are trying to attract an electron over to fill the gap, which becomes a channel for the movement of electrons. It is also because less of an electron, it will be positively charged. We call this semiconductor for the p-type semiconductor. So what happens when an n-type semiconductor is connected to a p-type semiconductor? When the positive and negative terminals of the battery are connected to the positive and negative terminals of the p-n semiconductor in reverse, the extra electron of the n-type semiconductor and the extra gap of the p-type semiconductor will leave each other under the influence of the positive and negative terminals of the battery, resulting in the electrons not being able to flow. That we put the battery positive and negative poles and then look at the reverse. At this time, the n-type semiconductor, more electrons will enter the p-type semiconductor to form an electric circuit, which is why the diode can only conduct electricity one-way principle. Then the light-emitting diode, in the end, what is going on? We enter the p-n semiconductor contact point of the microscopic world. Look at the electron from the n-type semiconductor to move to the p-type semiconductor process. Atoms with 5 valent electrons have more energy than atoms with 3 valent electrons. Then the electrons in the process of moving from high energy to low energy are here in the p-n junction to release energy. But the energy does not disappear into thin air, but are converted into light. But the p-n junction contacts in an ordinary diode are wrapped in thick material, and we cannot see the luminescence. So what to do? Clever engineers have their own way. We need a substrate to which we first add a layer of n-type semiconductors, and then cover it with a very thin layer of p-type semiconductors. Then we connect the 2 semiconductors with wires, which does not change the principle of operation, and the current can flow between the semiconductors and emit light. In order to increase its luminous efficacy, surrounded by a circle of reflective material, and then covered with a layer of transparent resin material to play a protective role, so that a LED light is completed.
Cutting off the appendix in the nick of time. How these people escaped from death in order to survive. They all happened and were even made into movies. In 2003, rock climber Aaron Ralston was hiking alone in Utah's Blue John Canyon when he had an accident. A huge boulder suddenly fell off. Before he could react, he fell down a gully with the boulder. Worst of all, his right arm was crushed between the boulder and the rock arm. At first he tried to pull his arm out, but with almost all his strength he couldn't budge the boulder. The pain quickly calmed Aaron down. He knew he couldn't move the boulder with just his strength, but since he didn't have a cell phone, he had to shout and wait for help. But 5 days had passed, and he still hadn't been rescued. Water and food had been depleted. Aaron could only survive by drinking rainwater and even his own urine. At this point, Aaron realized in this uninhabited rock crevice, the only way out was to save himself. So, he took out his dull knife. He made the wisest decision of his life, to cut off his arm to survive. Aaron sliced through his skin and muscles and sliced through his tendons in excruciating pain. but the blade was too dull to cut through the bone. At this point, the desire to survive had already overcome his fear. So Aaron shifted his position. He used the principle of torque to break the bone with the help of the rock. After an hour of torture, Aaron was able to get out without the aid of anesthesia. This thrilling experience was eventually made into a movie. Next, the toughest doctor in history. His story is a miracle in the history of medicine. Rogozov was a doctor at the pediatric hospital in St. Petersburg. In 1961, he joined a Soviet-organized expedition to the South Pole. There were 13 members of the team. He was the only doctor. On April 29th, he suffered an acute appendicitis attack. He was in excruciating pain. At that time, appendicitis had to be operated on, but he was the only doctor on the team. Who would operate on him? At first, he tried to control his condition with medication, but it didn't help at all. And the nearest hospital was thousands of kilometers away. So he had only one option. He had to operate on himself. After a day's struggle, he asked one of the team's drivers and a meteorologist to be his assistants. One of them held a mirror in his hand so that he could see the area better. The other held a light in his hand. Under local anesthesia, he made an incision 10 centimeters wide in his abdominal wall, but due to his nervousness, he accidentally cut his appendix. So he sewed up his appendix first. Then he used his sense of touch to feel for his appendix. Due to the loss of blood, he had to rest every 5 minutes during the process. It wasn't him who was the most nervous, it was the two assistants next to him. They watched him pulling out his own intestines. Imagine the feeling. Finally, after 2 hours, he had completed the operation and had been stitched up. On the 5th day after the operation, he was back to normal. But the photos his colleagues took of him quickly became a worldwide sensation. In that year, he was only 27 years old.
Have you ever wondered if you have to pump the sea water dry when building the piers of a bridge across the sea? The answer is definitely no. First, a few trained divers are needed, and then a temporary approach bridge is built to reach the location of the piers. The diver's task is to dive underwater and use explosives to blast away the fragile surface of the seabed. A drill is first used to hit the seabed to the necessary depth, which allows the blast to be optimized. The diver then aligns a blast pipe with the opening of the hole, which is used to place the bomb. Once the bomb has been lowered, the raised portion of the seabed can be safely and effectively blown away until a relatively solid seabed emerges. Once all is blown flat, the loose surface of the seabed is further cleaned using a high-pressure hose, and finally the knocked-down rocks are cleared from the surface by a crane. A steel-reinforced, wood-paneled structure is now constructed on this surface, the frame being a prefabrication of cubes, which is assembled on the seabed by workmen. It takes about 6 months to complete the assembly of the steel structure, and after 6 months, the surface of the steel structure is covered with a waterproofing sheet, and up to this point the concrete grouting machine is ready to go in. The grouting machine fills the whole steel structure wall with cement from this opening downwards. If the concrete is grouted directly in this way, it is easy to be mixed in seawater and cannot solidify properly, so it is necessary to use a special proportion of cement. Then connected to the seabed by segmental pipes, the concrete is poured in from above and deposited at the bottom of the steel structure, and then piled up layer by layer until it fills the entire wall of the abutment. When the concrete is completely solidified, then the seawater inside will be drained. The geology at the bottom of the abutment is still relatively soft, and it needs to be sunk 15 meters before it reaches a strong enough rock layer. But this wall is not strong enough for the time being, because the pressure of the seawater combined with the huge ocean currents makes this temporary concrete wall very unsafe. The first step was to install blasting machines, transportation pipes, worker shafts, ventilation ducts, etc. Next, a thick reinforced concrete slab was poured at the bottom of the site, and underneath the slab was the construction area, which was accessed by workers and technicians through this worker shaft. Workers and technicians enter the construction area through this worker's shaft. Workers are constantly digging out rocks and soil, and the construction process is carried out with the aid of various monitoring equipment. Injecting compressed air from this tube into the inside prevents water seepage by making the pressure in the construction space greater than the water pressure. The bottom of the wall is in the shape of a cutter, and during the excavation process, the entire wall of the abutment sinks slowly, guided by the bottom of the cutter, until it is dug down to a sufficiently hard rock layer. At this point the ground is made level, filled again with steel, carried away with its belongings, and then the pouring of concrete into it begins. Up to this point, the main body of the abutment has been built, and you can begin to erect the tower on top of it. Before erecting the tower, the surface of the concrete abutment needs to be sanded and smoothed, and then a thick steel plate is laid on the foundation. Erection of the tower are finished prefabricated parts of the mechanized assembly, until the final roof of the entire process is not complicated. The only need to overcome this fearful construction height. This is the construction process of the piers of the Golden Gate Bridge more than 90 years ago, and it has many pioneering techniques that have become models of modern bridge construction and are still being studied and used today.